But we're going to go over something that maybe you've seen before in a previous science class, but sometimes we need to measure the mass with what's called a triple beam balance, or there's different kinds of balances. I've got some triple beam and some quad or four beam balances, okay? So one of the mistakes folks make is they call it measuring the weight, but we're actually measuring the amount of material in something, not this space that it takes up or not how much gravity pulls on it, but it's called its mass. It's a very important property, and you can't change the mass of something unless you break it apart. If you move it around, it will always have the same mass. If you squeeze it or stretch it, it will always have the same mass, but its volume or its weight could actually change, okay? We use units of grams for typical things in the science classroom. Now, if we have a lot of grams, we could go up to kilograms, or a teeny amount of mass could be in milligrams or centigrams, but in here, our balances will read in grams. So let's take a look at some pictures of the readings on a balance, and this isn't going to help you with the actual measurement routine. We'll have to work on that in class, but the actual reading part is what I want to demonstrate for you here. Okay? Take a look at a few examples. So here's a picture of a typical measurement from a triple beam balance. And essentially the way these work is you just measure one digit at a time. On a triple beam balance, you'll know the hundreds place, the tens place, and then the ones and tenths place will be on a beam together. So in this case, the middle beam, where you see it 100, 200, 300, that's the hundreds place. But we're on zero there, so there is no hundreds place. It's just zero, so we wouldn't write that. So then we go up to the tens place, and you see how the pointer is pointing right on 30. Okay? If a pointer is ever in between two numbers, it means it's not locked into one of the little notches. There's some small V-shaped notches that you can see on here, and you can definitely feel them when you're using a balance. So it's got to be kind of clicked into that little spot. So this is on the 30. So our first digit is 3, and that goes in the tens place. And then on the lowest beam, we get the ones and the tenths. Although the tenths are far too small to have numbers next to them, it's kind of like a metric ruler. You can just count how many over for your last decimal place. So in this case, we are over past the 7, but not quite to the 8. So it's 7 point something. And that point is what we're talking about is the tenths. So I know it's hard to see on the video here, but I can tell this is actually on the third mark over out of the 10. And so that is 3 tenths, or we would say 0.3. So the mass of this is 37.3 grams. Okay? Let's take a look at another one. I picked this one in particular because students do get confused on these sometimes when the last beam is way over on the left side. But notice on this one, we do have the middle beam pointing to the 100. So we have a hundredths place, or hundreds, I should say, not hundredths. So that's a 1 in the hundreds place, and then we go up to the tens place, and it's pointed to 90. So we put a 9 in the tens place, and then on this lowest beam, notice we are not yet to the 1. What students forget is you need to write a 0 in the ones place, and then the small pointer tells you how many tenths. So if you count, again, each of these are 10 little marks in between the 0 and the 1, so those are tenths. So we are on the third one over. Again, this is by my eye. I know it's hard to see. So that means 3 tenths, or 0.3. Okay, so the total when you string all those digits together is 190.3, and then we always put the units of grams. Somewhere on a balance they should be marked. In fact, in this case, it's the tens bar is marked with the G, and so actually all of them are. You see the G's here. That's just to remind you that we're measuring in grams. Okay. Let's take a look at a quad beam balance, because you might see one of these in the lab someday for more precise measurements. This one doesn't look quite as realistic, but it is kind of nice in that you have to actually start at the top with the hundreds place and then just work your way straight down. So we're on the 100 on the hundreds place, so we would put a 1 in the hundreds place. We're on the 40, so we put a 4 in the tens place. We're on the 6. Notice the 6 here, the ones place doesn't have any additional lines, so we put a 6 in the ones place. And because there's a fourth beam, it's going to tell us the tenths place and the digit beyond that, which of course would be the hundredths place. So both decimal places come from this final beam. And so see how you see 0.1, 0.2, 0.3, 0.4. So it's 0.4 something. We're not over to the 0.5 yet. And if we look, we're on the fourth line over. Okay? So that means another digit 4. All right? So 146.44 grams is the measurement. Okay? So that's a quad beam balance, and we will have an extra decimal place, a hundredths place from one of those. You see, we call that a little more precise. So if you're doing an experiment, you've got to know a little more precisely what mass you have. This is the time to use a quad beam balance, or something even fancier than that, which we probably won't use this year and here, and that is like an electronic balance or something a little more sophisticated. All right. So maybe you've done this before, and this is review. We'll work on the actual technique of using the balance, but at least you'll know how to make the reading once you're done with it.